Day 2 of area. These area formulas might be a little bit more new than triangles and parallelograms from yesterday. Today we have trapezoids as our first shape. So area of a trapezoid. And you have your little trapezoid right here. And we have our height. So trapezoids their formula is different. I'll give you the formula. No, I'll label it first. So you care about the height. Whenever you see the height of a shape, look for that 90. The 90 is gonna kind of, that's the height. It's not this slant. It's straight up and down. And then you've got base 1, and down here you have base 2. Clearly these bases are different. That's what makes a trapezoid a trapezoid. You can also think of height as the distance between the bases, because if your trapezoid was tilted like so, you might say, "Oh, Mr. Michelson, this is really the height." Yeah, that's the height, but this is really what you're looking for, is the distance between the two bases. And the area formula equals base 1 plus base 2 times the height, and divide all that by 2. So all you do is you add the bases, multiply by the height, and divide by 2. Second shape we're going to look at today are, shapes. 2 of them. We have rhombuses or rhombi and kites. So let's get that. And they use the same formula, which is kind of interesting. Area of a rhombi. Remember, that's a shape where all the sides are the same. Could be a square or could be a tilted square. And of course, kites have some unique properties as well. This formula, though, in my opinion, not too bad. Area equals d1 times d2 divided by 2. The d1 and d2 is first diagonal and second diagonal, okay? So these are diagonals. And you might say, "Mr. Michelson, what's a diagonal?" I'm glad you asked. I will give you a picture right now. So, you should remember, though, a diagonal goes from corner to corner. So this is our rhombus. Remember, a rhombus has all sides congruent. And a diagonal goes from one corner to the other. So we could call that D1. And this guy goes from, again, corner to corner. We could call that D2. Now, if you switch these around, would you get the same answer? Yes, you would. So you just multiply this diagonal length by this diagonal length, and then divide by 2, and you've got your area of your rhombus. The kite uses the same formula, and I will draw it just so you have a picture. So here's our kite. And remember, a kite has 2 sides that are the same next to each other in one spot, and then 2 sides that are the same touching in a different spot. So, here we go. It's almost like the diagonals for a kite are really almost like the sticks you would use if you made a real kite. So you got D1 right here, and D2 right there. Again, if you switch your diagonals, it's not going to matter. All you do is multiply one diagonal by the other diagonal, and then remember to divide by 2. So that's actually it for these basic, or those area formulas, a little more complicated than yesterday's. Let's do some practice problems.